Hi everyone, here's my last thing for rewriting polynomials. It kind of ended up having quite a few pieces, but hopefully none of the pieces are giving you much trouble. This last one may be new for you. It is a really important trick. We'll use it later this quarter and we'll use it at other times as well. And the trick is completing the square. So this really boils back to the perfect square trinomials that we mentioned when we were factoring. So remember that perfect square trinomials factor into a perfect square like this. And it doesn't have to be x plus a, there's other forms, but that's what I want to focus on for this section. So this means that we're really taking x plus a times x plus a, which when we FOIL is going to give us an x squared. Our outside inside is going to be ax plus ax. So we're going to have two ax's, and then our last is going to be a squared. Okay, so here is the question I have for you. We want to be able to go backwards. We want to be able to figure out how to create an x squared plus 2ax plus a squared type polynomial so that it will factor like this. So I'm going to give you one, and I want you to, if you need to, pause and try and guess the answers to these before I do. This is a really good learning activity. So x squared, let's say we started with x squared plus 6x, and my question is, what do I have to tack on, or basically, can you find the value of a, comparing back up to this? So what do I have to tack on to make a perfect square? We're trying to build perfect square trinomials. Okay, so pause if needed. The idea would be that we're saying that 6 is our 2a, which means that a has to be 3, which means if I want a perfect square trinomial, I have to tack on a squared, which is 9. Notice that when you go to factor this, it does in fact factor into x plus 3 times x plus 3, which is x plus 3 squared. Okay. So I'm going to try another one and then we'll work on generalizing. What if you had an x squared minus 5x and you were trying to figure out, it's always going to be positive since it's a square, what do I add on to make a perfect square trinomial out of that? So again, we're saying in this case that negative 5 is our 2a, which means a is negative 5 halves, which means a squared is 25 over 4. And when you go to factor that, it might look tricky, but what you're going to get is you've deliberately made this so that the two will be the same. It's going to be, oh, I'm spacing out here. It's going to be our negative 5, it's going to be half of this number. Sorry, I'm spacing. So it's going to be negative 5 halves. It's basically going to be our a, right? That's what this says right here. So we find that a, we have to tack a squared onto our trinomial, and then when we factor, we get x minus a, x plus a, whichever it is, times x minus a. So this is x minus 5 halves squared. Okay, so now I want you to try and generalize. This is really what algebra is all about, is generalizing. What if I say, in general, if you have a leading coefficient of 1, so 1x squared plus bx, what would you tack on to make it a perfect square? So now I'm saying that b is equal to 2a, so I need to take b over 2 to get a, and I need to square it, which will be b squared over 4, right here. In fact, I'm not even going to write it that way. You can memorize that, but if you've seen it before, you've probably seen it not multiplied out. b over 2 squared, that's like the magic number. If you're going to complete the square, you take the number in front of x, that's called b, you cut it in half, and you square it. And then when it factors, you don't have to memorize this part unless you're really struggling with getting the factors. It's going to be x plus b over 2 times itself, which is x plus b over 2 squared. So to complete the square, let's just make sure I say it really clearly. On x squared plus bx, you would need to add b over 2 squared.